now I'm just gonna mic these. Here, I'll show you. All right, so this is a 4 to 5 inch mic. So that would be 4 inches, 400 thou, and then 3 lines is 75, and then 10, 11, 12, 13, 14. So that's 89. So that's 4489, and then you're in the middle because this is a 10th mic. Sorry, I'm not the best at explaining, but we are on the 6. See how that lines up perfectly? So that's 44896. We're 4/10 under target. So that's perfect. And we have established our 0 there. So that's where we're going to stay. All we're going to do is do that 6 more times on that side, and we're at our final dimension there. We got 156 thousandths to go. Gonna do a light stream of coolant on this one. It's not that big a deal. These end mills that I use for side milling, since I'm doing thin parts, the edges are burnt up on them. So that's why I'm using them for side milling, just to get the most bang for my buck there. And then I just take final pass or two. You want to be real careful when you're working this close to the vise. The reason I have it so close is you don't want much of this part sticking out. You want as little as possible. If you minimize stick out, you get a lot better cuts. Do the finish on that edge. Let's see. Real nice finish. We're just going to repeat that several more times. going to take about 30. And that'll leave us a real nice finished pass. Sorry I'm moving this thing so much. I know that's really irritating. Just bear with me while I learn what the heck I'm doing here. Lock it down on 0. A couple of tenths doesn't matter. Not on a job like this. But I'm a little bit OCD. See that move to a 1. Move to 10th. But we're going to fight the urge because I'm not crazy. As long as I'm not crazy. But I am self-taught completely. I've learned a lot from YouTube. I've learned a lot from old timers that have mentored me some. Your reference manuals, like for instance, that right there, Machinery's Handbook. I'm constantly referring to that. Everything you need to know is in one of these. You know, I feel like if you're not actively trying to learn, and if you're not constantly learning, you're not really doing your due diligence on something like this. And I've met, 80-year-old retired tool and die makers, millwrights, machinists, and they all will say the same thing, that you learn up until the day you quit the trade. There's just that much to it. And I have to agree with them. I've barely scratched the surface. It's a lot to take in. 1930s Cincinnati right here. Very, very, very good machines. I would say you'd spend $5,000 on a new ball door, which is definitely going to be nicer. But the $100 Facebook Marketplace purchase right here, been going strong for 2 years. You don't always have to spend money. Although I would kill for a 5 horsepower ball door buffer. Anybody out there, let me know. Cincinnati or Queen City long arm buffer, let me know. I will pay freight shipping. I will drive to you. I promise we're about to get into some fun stuff. Hang tight. We're going to keep on sets from here on out. Well, I do on sets. So I want to stop. I don't know if that's what you do. Okay, so someone do. Let's do a first round. Okay. Step down. Look at one. One, two. You do. Hit. And put it right. These are going to be something a little bit different. You may be saying, well, that looks like a dog's butthole. Well, you're right, because I'm doing serrations on the front of these. We are going to surface grind them because they also feel like a dog's butthole. I'll see myself out. I thought that was funny. Tough crowd. Anyway, I got earplugs in and I've left my dang grinder going. I'm going to go back to this bad mother right here. Caliper. 379. So we got some room to play with here. What the heck? Alright. I'll put you right in the action there. What we're doing here is just dressing. We're dressing that stone. Hopefully nothing goes boom here. When you're playing with grinders, that's never fun. Unless you're the one watching. Then it's hilarious. Uh-oh, we heard it. Alright. Dress it down. Very nice. Just to keep you all updated on a little bit of my life, this is Friday the 24th of February, 2024. I am from the future. And in the future, we use 60-year-old, 70-year-old manual surface grinders because we like repetitive motion injuries. These things will absolutely wear you out. Nobody wants to run one of these for an 8-hour shift. Anyway, it might be a little bit wasted. I do enjoy surface grinding parts. A lot of people think it's unnecessary. I'm not getting paid by the hour, or I would be eating ramen noodles and sleeping in a box. This is my side job. I take pride in the things that I make. Which is why I like to, make everything as perfect as I can. Of course, nothing is perfect. But I just like to do the best work I can. As my dad says, and he is the person I look up to the most, if it's worth doing, it's worth doing right. And who doesn't want to be proud of what they make? Are these jaws perfect? No. I'm not a robot. I'm only from the future. There's a certain manufacturer that will make you a pair of these, and they will sell you jaws that will explode under heavy use. You should be able to do everything except from detonate a nuclear bomb in your home garage and not tear these up. I'll post some videos sometime and we'll sledgehammer the holy crap out of one of these. And I'll show you what I mean. You're going to break your silly vise before you break these. Your vise isn't silly, I'm just making a point. A2 tool steel, heat treated, 53 to 57, 53 to 58, Rockwell hardness, C scale. What have I done? Alright, you guys hear that, don't you? This shouldn't be happening. Getting some bad vibrations. Alright, we're touched off. What I'm going to do here is actually zero my scale. We are going to zero out very carefully without moving that. You get the point. We'll take a pass here at our pretend 0. I'm sorry, I recorded the entire video of the handle that nobody really wanted to see because I am a buffoon, ladies and gentlemen. Anyway, that is a beautiful finish. We're going to serrate these now. Kick the magnet. Turn the lights off. Back to everybody's favorite tool in the shop, the girl that starts every time. Lived through a world war. Probably made during wartime like every great machine. I think 30s, could be 40s. It's all the same unless you live through that, and then I'm terribly sorry. Generations are several orders of magnitude tougher than we are, and a lot better people. Check this out. With our depth where it's at, this right here is going to be the top of your tooth. See that? That's going to be far too flat. So what we do, it looks like you need to take a whole lot more off. You really don't. We're going to come down in each groove right here by about 5 more thousandths. We're going to take another pass across both. Zero. The reason I'm not going to indicate the vise and do them both at the same time, we have to cut a chamfer right there on the top of this piece, which means we will need it perfectly indicated to there because we're going to be using a end mill, an actual end mill, not an insert. Hold on a minute. Focus. Now you'll see the teeth start to appear. to use your imagination. Once we do some crosses this way, you're going to have square teeth, which I suppose is better than no teeth. You know who you are. Somebody help. You got an ouchie? Tell you what is perfect for these. Let me show you something. Just kidding. Let me show you something over here. Just kidding. Right here. Those are bent. Where are they? We'll use this pair. It's a new pair. These are electronics tweezers. They work perfect for getting metal shavings out. Here we go. And why don't I wear gloves? Because you don't want to be spinning in this. Or that. That would not be fun. Don't want to spin in this either. You know, my hand only twists about that far. So, no gloves. Which is another thing I was always taught. Rotating machine, no gloves. Because I want to be here for a while. And keep the tops up this way. That way I can pick where I start instead of where I'm going to land. Alright, I'll bring you back when this is done. You can watch the montage. Alright guys, there's one jaw. Since I did not reset my y-axis, come all the way back to 0 and start on the next one in the same spot. There you go, there's a good angle. You can see the tops of the teeth are still flat. See if we can focus here. You're still going to have that surface ground look in the tops of the teeth. Very cool. What in the heck? There we go. We got 6 to take the chamfer on. This will be the edge right here. Same thing as before. Hello, shop cat. Bye-bye. Guess he's going outside for the day. Getting a little loud in here for him. Everybody's favorite process. Just a quick one. Going to be changing end mill out. There's probably a better way to do this with the CNC machine, but I'm not smart enough to figure that out yet. You know, I could use like a chamfer. Could use a chamfer tool, couldn't I? I mean, I've got other end mills, but I think the best way to do this is just to feed down with a really nice end mill, a hefty one, about a 5/8 probably. Cheers. No metal shavings in it. The reason the head of this machine stays at a 45 is because the worm gear is worn out. So you could tilt this head, you know, with it up and down straight. You could tilt it 45 left or right and still get this same pattern, you know, 30 degrees. But with that worm gear worn out, I have to tilt this head by resting the head on my shoulders and spinning the worn out worm gear. And that's about a 300-pound head. And it doesn't fit in there. Always. Close your eyes, kids. Kind of idiot puts a zip tie right there. Me, that's who. Yeah, I didn't think that through at all, did I? And click. There it is. Ah, help! Help! And what we want is the 45 on this side. We want to indicate the tops. Really want to make sure everything's clean. This is a noticeable, very noticeable issue if one does arise. Snug it down. And of course, you can't see what I'm talking about. Wow. Okay, so I took the parallels out. I put the jaw in there. That way we're cutting with this end mill on this side. I'm going to cut on this side. On the back is going to be our... Whoa! Things just got real. Hope I didn't scare you too bad. I know you scare pretty easily. I recently had my brother-in-law 3D print a Bridgeport knee adapter that he found on the... well, I mentioned it and he got it for me for Christmas. He did that. But we're going to see how long it holds up. So far, so good. Been used a few times. Anytime I got to travel pretty far on the knee, I use it. Like this. Uh-oh. My battery. Hold on. It didn't hold up. Back to the drawing board. Maybe a hex shaft where I can throw a socket over. I'm sorry. We're going to come down. We're going to get all the chatter we can get on this part. As much chatter as possible is what we're after. We're going to really feed the air to this. No, we're not, because the video camera. We're going to burn the end mill up for you guys. Don't say I never did nothing for you. The very last step we're going to be doing before heat treat, drilling and counterboring the holes. And by that I mean, here's an example. Just some countersunk holes. Counterbored, sorry. We don't do screws here, unless requested. But I just countersink these for low profile socket head cap screws. Remember to put parallel sides in our programs. Now you want to keep all the chips out from under your parallels and out from behind them to be as accurate as you can be. Of course, nothing's perfect, but set these vise stops. I like to set them up at 0 left is what I call it. And quite simply, I just made it up to a known flat surface like this square here, the precision square. It is if you clean all the dirt off of it. And I just set my stops against that. You know, if I haven't had that program opened for this particular model, I know start at vise stop left. And then I put a comment in there for my parallel sizes, for my height. I don't move the knee on this machine unless I have to, and I zero it. I don't have a digital readout, but I zero it with a dial indicator on the boxways. But I will be buying a digital readout. If I drop this one more time, we're going to chuck it in the woods. I'm going to go buy some new ones. Trying to hold this jaw. I need to clamp it on that flat face. 1.5 inches. Let's take a 1/16 out of it. Help me do the math. 1 7/16. And I don't have any. I've got a parallel keeper on this this vise too. They're that handy. Please get yourself one. You're really stressing me out. 0.373 on the dot. Gonna mic it right across one of the faces. Hold on. I need a good vise over here. Wish I knew where to find one. 1.376.5. So we got, what did I say? It's 3.5 thou. I'm gonna start with the highest one, which are the serrated pair, which is to be expected. I did surface grind those down. So in order for that vise stop to work, we're gonna have to use this bad boy again. Now the fun part. My brain works better if I build all my jaws the same, because I'm known to screw up occasionally. By occasionally, I mean about 1 out of every 4 things I try. Okay. Oh, you see this? That's called the nut buster right there. What we're going to do is find the edge with, wait for it, an edge finder. It finds the edge, hence the name. I like to get the grime out of these every so often. So we're going to come down. I was always told to run these at 1,000 RPMs. I don't know if it's real critical. And I zero and I check it a few times. Come over, give her a flick. There you go. 1/10 off on the X. So we'll go up. Now you want to move over the radius of your edge finder. This is a 1/2 inch edge finder. So you know what a radius is. Half of your diameter. So we go 250, 0x. Now, our spindle is sitting on the side of this part. What we want to do is find the width of the part, which is 4490. We want to go in half. What is that? 2.245. So we'll move over half of the part to put our center line right in the middle. Now I just like to do a quick verification that I did indeed make this part correct before I bore the holes. Just very quickly. 4485, so half of 4485 is 2 inch 2425. So 1, 2, 2425. Focus. We need to find 3/4 inch from the bottom, which puts us at our center line on this plane, horizontal plane, for our bolt holes. So how do we do that? We indicate off a jaw. Since it's 750 from the bottom, we're going to come to the bottom of our part. We've already zeroed our X, so we haven't lost it by doing this. We're going to come down in line with the jaw. That's where we'll meet. Give her a flick. Not more than once, or you're playing with it. So we zero Y. That looked like it moved over too much. Be real careful. Edge finders are highly accurate if you are accurate at using them. They can be insanely inaccurate. So we check it a few times if we're unsure. We just found the edge of the part, right? Put you here to explain better. So we're already the radius into the part, 250, because we're talking center line of our spindle. That is where our point is at. If you think of a coordinate system, we're already 250 in. We're just going to go 500 in. And once we're 500 in, is 0. And we're on our 750 mark. I'm really enjoying this because I talk to myself anyway. So this makes it a little more understandable. Turn the spindle off, break it. But I actually grind a flat in the mill. Just a tiny flat. But that keeps your Z height the same, because with this machine, that's critical. You have about 5 inches of travel on your Z, and that's it. I will be replacing this with a CNC bed mill one day, if not a machining center. If you're going to get a 3-axis CNC, get a bed mill. Don't get a milling machine, a knee mill. Get a bed mill. Now this is a fine machine. There's nothing wrong with it. It's helped me tremendously. You don't have the travel that you really need for the 3rd axis. A lot of people, even with the 3-axis machine, will just use it as a 2. I don't do that. I use all 3 axes. We're going to 0. First, crank our RPMs back up. We are going to take a piece of paper. I'm sure you all know this trick. We're finding Z0. And I just eyeball it until I get close. And then I just do 1 thou down steps. You want it to grab the piece of paper from you. Or at least start to feel a little drag. Like that. Fixed it. Remember, we are on part dead 0, is what I like to call it. Program. Tool. Tool library. Set tool, make sure that's right. Our inner radius is 347, so he's probably using 5/16, 18 socket head cap screws. He wants that 347 on the diameter. Complete diameter. You want to half that. Circle. Helix. Teach position. X. Teach Y. Teach Z. Plus 0.01 plus 10 thou is our start. That way we don't ram down into the part. So our Z end is going to be at a depth of 188. So Z end is teach minus 0.188. Enter. Radius 347 is the diameter, not 347 inches. 347 divided by 2. Our pitch, we're going to go 60 revs per inch, 60 revolutions at 10 inches a minute. Feed rate. Start angle 0. Use. But that is right in the middle. So we do have a 3 1/4 bolt spacing. So half of 3 1/4 is what? 1 5/8. We will minus 1.625. If you go to circle, do a pocket, it's going to keep your same X and Y and Z, but we want to start our Z right there. We want to end our Z 188. And I actually told you wrong on the last one, so remind me. And I don't drill these because it's easier just to do a helix. It's essentially drilling with an end mill. So you're ramping in like this. You know what I mean? And there's our radius. So now, that's our first hole. Boom, boom. All I do is go to step functions, and I'm copying steps 2 and 3. Use. Use means okay. We're going to move over from our left hole, our bolt spacing, which is 3.25. Enter. Cancel. Sorry. Plus 3.25. Enter. Leave everything else the same. Plus 3.25. Enter. Use. And that's it. And these jaws will be ready to heat treat. So all we're going to do is hit go. So I hit go, set tool, go. So it just takes it in steps. I set it to 12 passes. never took a serious video of anything until I started this. So. All right, now we're moving over to 3 1/4. Second hole. And since I'm standing here is why I'm blowing the chips out. It gives a little cleaner cut, doesn't wear your end mill out as fast. Most of the time I'm not standing here, so I just let her run. Blow it off at the main end. This is where CNCs really shine. You know, without a rotary table, you're not doing this on a manual machine. Sure, you can spin in a circle, but you're not going to be accurate. Let me show it to you here in a second. 1 down, 5 to go. Come back against our stop. Program run. Now, as I've said before, I'm not college trained with this. I haven't done any journeyman programs. I'm 100% self-taught, obviously by watching people like A-Bomb, Steve Summers, Keith Rucker, Brian Block, Tom Lipton. I watch all those guys. Every single video they've ever posted, all of them. I've watched Mr. Pete, Abe. You know, there's just so much knowledge on YouTube that if you want to learn it, you can. It just takes being dedicated to learn it. I have an electrical degree, and I want to say that it is maybe 10% as complicated as machining. I really believe that machining is one of the highest skilled trades there is. You know, I don't know if you've ever met, any of you guys ever met millwrights or tool and die makers. They are some of the smartest people. You can learn anything from those guys. All right, I'll bring you back. I've got 4 more of these, this many, for those in the back. Got 4 more of these to make.